Now, from the Ethernet connection, where you're actually trying to get internet access, trying to connect to on your data or trying to connect to Wi-Fi. This is the internet access. Then the internet protocol being used after sending the message. When you send the message, the internet protocol being used here is the version 4 IP address. This is the, sorry, let me go to this one. The version 4 IP address. Yeah, the internet protocol being used here is your source IP, then the destination IP. This IP is the server IP of where I visited earlier, where I visited this website I actually visited here. Sorry, the server is not even coming up. So let me just go back here. This IP is the server of the IP server that I visited, which is here, the internet transmission protocol. This is it, port 80. Uses port 80 because I visited HTTP protocol. Yeah, I visited HTTP protocol, not HTTPS. Then look at the application I actually use. Look at the application I actually use. If I should cancel this, now, try to capture another packet and try to visit another site, you will see how the thing will actually work. Let me try to start capturing again for you to see. Let me start capturing again for you to see what I'm trying to say. So let me visit a particular site for you to see what I'm trying to say. Capturing the packets, because if you want to check for HTTPS, you don't type HTTPS on Wireshark, you type HTTP2 on Wireshark for you to get the HTTPS packets. You can see that there's UDP. Let me stop the packet and show you. You can see that there's UDP here. This UDP is actually capturing the core. This chat we're actually doing is capturing the chat we're actually doing here. You can see this is my source IP. This is my IP address here. This is my source IP address here. Let me show you from this internet protocol here. This is my source IP address. This is the server of the Google Meet we are using. This is the IP address of the server. This current this current Google Meet we are using. This is the IP address of the server. Then if you go down, you see that the protocol being used here is datagram, UDP, which is the datagram protocol, here. Look at it now. This the source, the port of this call we are doing now is 3000. This is actually an example of it's a user port because we're actually using it for now. Another person can actually use a Google Meet. They will still assign the same port, this port number to the person. So you can see that user datagram is because we are actually on call, and this call is actually the packet is seeing it as maybe is seeing the packet as user datagram that is very, very fast. Is not connection oriented. Yeah, it's not connection oriented. That's why you can see user datagram protocol here from the port source, from the source port numbers to the destination source port number. Then if you come to this data here, you can see that is data. This data cannot be encrypted. You cannot see what they are writing here. It's because of the code we're actually doing. And this is actually, if you can crack this code, you actually see that is the voice code, is the voice I'm actually using to explain to you this. If you can crack it, you will see that this thing is because of the core you're actually on. That's why you can see data here. If you actually visit an HTTP packet, you will know that you will see HTTPS packet. This last one, which is the application part of it, will actually show HTTPS. you see HTTP, the secure version of HTTP. If it's FTP, if you visit an FTP, if you try to send file via internet, maybe you try to upload your file in your maybe Google Drive, what you will see here, and you actually capture the packet at that moment. What you actually see in this last part is you will see FTP or FTPS to capture data. So that's how TCP/IP protocol actually works. That's how TCP/IP protocol actually works. This is the backbone of the networking. It's backbone of networking. There's the backbone of networking. If you want to, if an intruder want to actually maybe capture somebody that is maybe get somebody password now, what the person actually need to do is just what the attacker actually need to do is just to connect on his Wi-Fi, maybe disable the password and allow people to connect to it. When people connect to it, you just on Wireshark packet like this and just leave it to be capturing packets. You just leave it to be capturing packets. Maybe after some time, when you stop capturing the packets, you just go home and just filter HTTP requests, maybe HTTP post to see if there's any password. Maybe if they visited any vulnerable websites that they inserted their password to it, and from there it has gotten the password and you can actually do whatever you want to do with it. By God grace, when we start our practical class, because we're actually starting with Wireshark, tomorrow we're actually going to be doing subnetting tomorrow. When we start our practical class next week, so we'll use a vulnerable website to capture, we'll use a vulnerable website, we'll sign in our details, a fake details on it, then we'll use Wireshark to capture those details. You will see it live and direct how Wireshark is used to capture username and packets of an individual. So that is all about TCP/IP protocol and OSI model. Please, I'm going to compile a note and understandable note and send to you guys. So if you have any question to ask on this particular topic, you can just unmute and ask.
Sir, actually, I wouldn't say it's a question though, but just that like when you stepped into this practical part where you were giving us like illustration on your system, I was a little bit lost because I was not getting all of the numbers that was on the screen, the code, all those stuff. I not really understood everything that you were like explaining because like it's not even like sometimes I was trying to like follow your monitor, like your monitor signal, like the small arrow to see where it's pointing and everything, but I can't just get all of them wrapped up in my head. So
Yeah, I get your message. Sorry, I'm really sorry about that. And is it about the Wireshark? Is it the Wireshark part? Is all these numbers you are trying to see if you can get?
yeah, exactly. Like for example, now the port number you spoke about now, like you said in total there are like 5,000 or so. I'm thinking in my head. How do
Yeah.
I like cram all of those stuff in my head like I've had?
No, you don't.
No, you don't.
You don't need.
You don't need.
Can you mute? You don't need to cram port. You don't need to cram port number in your head. All the one you just need to cram is the system port. That's the one you just need to know. I don't even need to cram it in your head. You don't need to cram it in your head. Like if this if we let me check HTTP packet now. Checking HTTP packet here now. You can see that the destination port is 80. Just have in your the only port you need to know as cybersecurity personnel is the system port, because the user port normally changes. Is changes. It's not permanent. It's temporary. It changes. That it changes. So the only port you need to actually know, the common port you need to know is maybe the HTTP port, the FTP port, the SSH port, the SMTP port. Now, why do you need to know all these port numbers? Is this system port number is that if you are a SOC analyst now, and maybe you are asked to watch log, the log you're actually going to watch is Wireshark you are actually going to be using. or using other network, other sniffing tools, like let's say T-Sharp or other sniffing tools. Now, when you're asked to watch packet now, or as a maybe as a stock analyst, they capture packet and send to you and ask you to analyze it, like to check if there's any vulnerable sites anybody visited maybe in the work activities. Now, what you will do is that maybe you check this first packet now. You search for HTTP. You search for HTTP here in your search bar here. You search for first thing you search for HTTP. Sorry. HTTP. If there's any HTTP request here, then you check. All what you just need to do is just to write down the source IP address, which is something like this. Like the source IP address. This source IP address is the IP address of the particular users, maybe in that organization that actually visited that site, because that user is putting the organization at risk. You visiting HTTP sites, you are putting an organization at risk because hacker can actually access maybe the organization data from your own computer here. So the first thing you check is this HTTP, just for you to search for it. This is HTTP. Now let me search SMTP for you to see. You can see there's no SMTP file because you didn't actually send any email message. So just for you to know this protocol. Now if you search for SSH now, you won't see anything because you didn't connect to any server. You didn't connect to any server here. And if you also search for FTP, there's no FTP site here because you didn't send message. We didn't upload message online. So all what you need to just know is just to know those protocol and the port assigned to it. And the one you need to know is the system port. That's the one you need to know. The FTP, the DNS. Now let me check if I will see DNS here. Now you can see now there's DNS here, which is port 53. If we come here now to check, you can see that this is the source port, which is port 53. And this is the destination port. This destination port is user's port. It's changing. You can see this is a DNS, that is standard query response. This is a DNS. And this DNS is using a user datagram, which is the code we're actually making right now. So what you actually need to know is when we are treating Wireshark, I'm actually going to explain how to search, because what you actually need as Wireshark is for you to search using your taskbar. You can actually filter before you start capturing packets to avoid a lot of load. And you can actually filter after capturing. Maybe you want to capture a lot of data and you want to check more. You can capture without filtering. After capturing, you now filter your this thing. You can see that we saw DNS now, and we actually the port number of DNS is 53. If you remember, you can see it here. This is the port number. This one, 53 here. You can see port number is 53. So all what you need to know, this is the port number you actually need to know here is the system port and your IPv4 address. Yeah, IPv4 address. That's what you just need to know. So that is about knowing about port. You don't need to know the user's port. You don't need to know the dynamic port. You just need to know the system port, and not all the mostly used ones like the HTTP, HTTPS, FTP, SMTP, SSH, Telnet, and SSH is the secure version of Telnet.